Hi friends, welcome to my YouTube channel. This is second part of lecture number 16, and in this lecture we will study parameter calculation for one phase half wave uncontrolled rectifier with RL load with freewheeling diode. First we will take average value of output voltage. Average value is equals to 1 upon T integration 0 to T V naught dt, and we know that we get output voltage from 0 to pi. Okay, and from 0 to pi equation of output voltage is same as that of source voltage. That's why we get 1 upon 2 pi integration 0 to pi Vm sin omega t d omega t. On integrating we get Vm upon pi. Second is average output current I naught. I naught is simply equals to V naught average by R. So putting R in this V naught average in denominator we get I naught average is equals to Vm by pi R. Next is what is RMS value of output voltage. So simply we can calculate RMS value like that, root 1 upon 2 pi integration 0 to pi Vm sin omega t whole square of it dot d omega t, and I naught square, I naught RMS we can get by taking square root of 1 upon 2 pi integration 0 to beta, here square of equation of current dot d omega t. This is the procedure to calculate RMS values of voltage and current. But from exam point of view, this is not important. Only these two formulas you have to remember. Okay. Now next is load is current step. Why load is current step? We can clearly see here that voltage and current waveforms are not similar. That's why this load is current step. And this is half wave uncontrolled rectifier. We know that in case of current step load, output power is given by V naught average into I naught average. So simply multiply the average values of both voltage and current, we get the output power P naught. To calculate the power factor, we know that input power is equals to output power because the diode and freewheeling diode are ideal and there are no losses across this diode. That's why for loss free circuit we get input power is equals to output power. And what is input power? That is equals to RMS value of source voltage into RMS value of source current into input power factor cos phi, that is equals to V naught average into I naught average, which is output power. So from this equation we can get this input power factor cos phi. Now next, what is conduction angle of this main diode? Here we know that the main diode will conduct from 0 to pi. Okay, after pi what happens? After pi, when current shifted to freewheeling diode, then from pi to beta this freewheeling diode conduct. Okay, so main diode is conducting here from 0 to pi, that's why conduction angle of main diode is pi. And from pi to beta what happens? From pi to beta freewheeling diode conducts. That's why conduction angle of freewheeling diode is beta minus pi. Okay, here this freewheeling diode conduct. Okay, so this is important. Now what is beta? Beta is the angle up to which we get current. So beta is between pi to 2 pi. It means beta lies in this region when discontinuous conduction mode. And when beta is greater than 2 pi, then what happens? We will current waveform like this, and that's why in case of continuous conduction this beta is greater than 2 pi. Now what is peak inverse voltage? Okay, so here we can clearly see that peak inverse voltage is equals to Vm. This is plus because this negative sign is included in this term inverse. Okay, so this is plus Vm. So peak inverse voltage is plus Vm. Now we have to calculate the circuit turn off time Tc. We know that this diode is reverse bias for this angle pi. Okay, so we can put omega Tc is equals to pi, so we get Tc is equals to pi by omega. So circuit turn off time is pi by omega. This is all about the parameters. And one more important thing here, freewheeling diode current flows from this plate pi to beta when freewheeling diode conducts. Okay, and source current is not equals to output current in case of RL load with freewheeling diode, while in all other cases this output current is equals to source current. Only this half wave uncontrolled rectifier with RL load and freewheeling diode is only exception where I naught is not equals to IS. So this much concept you need to remember in this lecture. I hope you like the video. Thank you. Jai Shri Ram. If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.